Hello everyone, welcome to my channel Excel Achievers. We are doing the questions from HP set 2024 and this is the section complex analysis. This is the question number 48. The question is the value of integration gamma real part of z dz where gamma is the ellipse gamma t is equal to a cos t plus iota b sin t comma t belongs to 0 to 2 pi and a and b are greater than 0 is. So what will be the right answer? Let us start solving. Okay, हमें पता है कि our z is equal to r of t, right? Then dz will be equals to d by dr of t. Since r of t जो है हमारे पास a cos t plus iota b sin t. So d by of drt will is equal to a minus sin t plus ib cos t dt, right? Now look at the question. We have given real part of z and dz. So real part of rt will be a cos t and the dz will be d of r of t. So this, let us put in this equation. What we get? We get gamma a cos t minus a sin t plus iota b cos t dt, and our t is from 0 to 2 pi given in the question. Now let us solve this integration. This thing is going to be multiplied by this thing. We get a minus a square cos t sin t plus iota ab cos square t dt integration 0 to 2 pi. Now let's solve it differently. This minus a square cos t plus multiply by sin t dt plus iota ab, these are the constants, so we take them out and I get left with cos t square dt. Now I know this can be become the formula of sin 2t. How? All I have to do, multiply and divide by 2. So I left with 2 cos t sin t dt plus iota ab. Now I think you have done this thing many times. Okay, that cos 2x is equal to cos square x minus sin square x, right? And if you look at this one, so cos 2x is equal to cos square x, so minus 1 minus cos square x, or cos 2x is equals to 1 plus 2 cos square x, or cos 2x minus 1 upon 2 is equal to cos square x. So what I will put instead of cos square as cos 2x minus 1 upon 2, or I would say So here will become 2 by cos 2t minus 1 upon 2 dt. Now minus a square upon 2, 0 to 2 pi 0 to 2 pi, here comes sine 2t dt plus iota ab 0 to 2 pi. 2 is common, I left with cos 2t minus 1 dt. Now we can integrate, I left with a square upon 2, 0 to 2 pi sine 2t we will become minus cos 2t upon 2 plus iota ab upon 2, 0 to 2 pi cos 2t will become sine 2t upon 2 minus t. Now let us put the values. What I will get, minus a square upon 2, minus minus plus, or 2 will also come because this is a constant. I left with cos 2 2 pi minus cos 0, okay, plus iota ab upon 2 and sine 2t यानी sine 2 2 pi upon 2 minus 2 pi minus sine 0 upon 2 minus 0 bracket close. Next, now I left with a square upon 4. Cos 4 pi will be 1 and cos 0 1 plus iota ab upon 2. I know sine 2 4 pi upon 2 will be 0, 0 minus 2 pi, and this will also 0. So what I get at the last, minus ab upon 2 multiply by minus 2 pi. 2 cancel out with 2, I left with answer minus pi ab or pi I ab. So our right answer is minus pi iota ab. So this one, option 1 is our correct option. Now let's go for the next question. Question number is 49. The value of integration e power z upon z minus 2 dz, where gamma is the positively oriented circle mod z is equal to 3 is. So this is the positively oriented circle gamma. So we have this z mod z is equal to 3 and radius 3 means radius, so this like this minus 3, this is 1 and 2 and 0. So our singularities here, z is equal to 0 and 2, both are inside the disk. Therefore we are going to apply Cauchy's integral formula. That is 2 pi I f of a is the singularity, is equal to integration f of z upon z minus a. This is an important. And what is positively oriented circle means? Now Let us solve by this method, Cauchy's integral formula. So let a is equals to 0, then f of z will be Ez upon z minus 2. So f of 0 will be E0, 0 minus 2 gives you minus 1 upon 2. So by Cauchy integral formula, we get 2 pi I multiplied by minus 1 by 2 integration f of z and Ez z minus 2 upon z. So 2 will cancel out 2. I will get minus pi I dz. Now when our singularity is 2, so singularity is 2 yani a is equal to 2. So our f of z will be Ez upon z, or I put the value of 2, E2 upon 2. So Cauchy's integral equation will become 2 pi I E2 upon 2 is equals to Ez upon z upon z minus 2 dz. 2 will cancel out 2. I left with E square pi I. So this and this will be added. I get E square pi I minus pi I, or pi I will take as a common. E square minus 1 is our right answer. This is our right answer. So let me take this one. Now let's follow the next question. The next question is, so this is our next question, question number 50. The Taylor expansion of f of z equals to 1 upon 1 minus z about z is equals to iota, and these are the expansions. Okay, so when I write the Taylor expansion, we write it as a n z minus z naught n 0 to infinity, and an is equals to fn z naught upon n factorial, and z naught is here iota. So let us first find an. A1 will be equals to, or a naught is equal to f of iota. So what I get, 1 minus iota. Simple. Next, a1 is equal to f dash iota, means minus 1 upon 1 minus iota square. A2 f double dash iota minus 2, and there is a factorial. This is 1 factorial, this, and here I will get 2 factorial, and 1 minus iota 3. 2 factorial will cancel out with 2, and so similar way. So if I write it down, I'm going to have the Taylor series 1 upon 1 minus iota z minus iota plus 1 upon 1 minus iota square z minus iota 0 and their power 1, and 1 minus iota power 3, and there is a minus 3 minus 2, sorry 1, and there is a 2 3, 1 minus iota 4, there is a z minus iota 2, z minus iota 3, and so on. So its expansion will be n is equal to 0 to infinity 1 1 minus iota power n plus 1 z minus iota n, and there is a minus 1 power. Also mod z minus iota, we have given z is equals to iota, so iota minus iota less than under root 2, therefore our right answer is option this one is our right answer. Because we have given 1 minus iota, right? So 1 minus iota, so if you go here 1 minus iota, so this is eventually less than is equal to 2. Okay, so this is our right answer. Now let's do the next question. Our next question is 51. The maximum modulus of z square minus z in disk z such that mod z less than is equal to 1 is. So हमसे पूछा गया है कि इसका मैक्सिमम मॉडुलस कितना होगा. हमारा f ऑफ z गिवन है z स्क्वायर माइनस z, राइट, एंड द maximum value of f of z where mod z is less than is equal to 1. If you go z is less than is equals to 1 means 1, radius is our radius is 1. So let me erase it and redraw it. So and this is 1 0. So now we will put the values maximum of z square minus z किधर आ सकता है. If I see minus 1 0 and 1, बाउंड्रीज पर भी चेक किया जाता है. So let us check on first on 0. So z square minus z will give you 0. If you put 1 you will again get 0. If you put minus 1 then you will get 2. So or you check on other points like iota, minus iota, or anywhere in between, you will find the maximum of mod of z square minus z is 2, right? So our right answer is 2. So that's it for today. If you like my videos, please share and subscribe. Thank you.